tangent function. Complete the table below for values of tan x. Now once again we can use the cast diagram, and we can use some standard values that we know. So tan of 30 degrees is 1 over root 3. Tan of 45 degrees is equal to 1. And the tan of 60 degrees is root 3, which is approximately 1.7 as far as we need to know for the graph we're going to be drawing. Let's just quickly work out 1 over root 3. So 1 divided by, and this is 11 divided by, 1 divided by the square root of 3 is about 0.58. So 0.58, 0.6 is about as well as I'm going to get this on the graph I'm drawing. The tangent of 0 is 0. Remember also that tan x is equal to sine x over cos x. We'll mention that again slightly later. And the sine of 0 is 0. 0 divided by 1 is 0. So tan 30 is then going to be 1 over root 3. This one will be 1. This will be root 3. Now the interesting one is when we get to 90. The sine of 90 is 1. The cosine of 90 is 0. So we have 1 divided by 0. So that's actually undefined. It goes off to infinity as the angle approaches 90. Now moving into the S quadrant, we know the tangent will be negative. At 120, we know the associated acute is 60, so that's going to be negative root 3. This one will be negative 1. Negative 1 over root 3. And then the tangent of 180, sine 180 over cos 180, is 0. For 210, we're in the T quadrant now, so it's going to be positive. 210 is going to have an associated acute of 30, so it's going to be positive 1 over root 3. Then this one will be 1. This one would be root 3. And 270, once again, we're going to be dividing by 0, so that's going to be undefined. Then we're moving into the C quadrant. The associated acute would be 60 for 300 degrees. So that's going to be negative root 3. Then we're going to have negative 1 over root 3, and we're back to 0. We now want to draw the graph of y equals tan x for values of x from 0 to 360. The tangent of 0 was 0. Tan 30, we said that was about 0.6. Now, I can't really draw it that well on this graph, looking at the scale. The tangent of 45 is 1. Tangent of 60 is about 1.7. And then we said that it was undefined at 90 degrees, and we get this thing called an asymptote. The graph actually goes off to infinity up here. So it goes like this. You can't take the tangent of 90, but if you actually start doing on the calculator tan 89, tan 89.9 and so on, you'll find the values get very, very big. So it goes off up this asymptote. And we know that there's going to be another asymptote at 270. Tan of 180 we said was 0. So for 120, it's here. 135 is at negative 1. 150 was about 0.6. And so this one goes through here, but goes off to negative infinity down here. And then here we've got 210. It's about 0.6. 5 is 1, 240, at 1.7, and then that's going to go off up the asymptote here. And then over here, we know it's 0 there. And 330 is about 0.6, negative 0.6. This one's going to be negative 1. This one's going to go there. And so it's going to go down and off to infinity down there. So what you can see here is the period of this one, because this is a complete one. The period is actually not 360 like the sine and the cosine. The period is actually 180. So now I have the tangent graph, this time marked off in radians. Remember, we have these asymptotes, pi by 2 and 3 pi by 2. And the period is pi. This is a complete one here. Now let's compare with the cast diagram. So this is 0, pi by 2, pi, 3 pi by 2, and 2 pi radians. And remember, A, S, T, C. So here we'd expect the curve to be above the axis, and indeed it is. In S we'd expect it to be below. So between pi by 2 and pi we can see the curve is below. Pi to 3 pi by 2 in the T quadrant we'd expect it to be above the axis, and indeed it is. And then from 3 pi by 2 to 2 pi in the C quadrant we'd expect it to be below, and there it is. Now finally here, and let's just put these asymptotes back on, we have the blue curve, which is the curve for y equals tan x. If we look at the pink one here, we can see that that is the cosine, and the red one is the sine. Now we know that tan x is equal to sine x divided by cos x. So we get these asymptotes every time the cosine is 0. So we can see that's there and there. The cosine is 0 at those points. And that means we're dividing by 0, which we're not allowed to do. That's why we get those asymptotes. We can also see here that both the sine and the cosine have a period of 2 pi, but the tangent has a period of pi.